Good day everyone, and for this lesson we're going to discuss the concept of the Squeeze Theorem. Let's go. Now, to introduce this topic, let us consider the real life scenario of three persons. Let's say we have Mr. John, Peter, and Norman. So here's the given. Peter eats too much compared to John, while Peter eats less compared to Norman. Let's say there's a pizza delivery. Now, they're trying to eat their merienda time. Now John ate 80 calories of pizza. Then Norman also ate 80 calories of pizza. So what's the conclusion based on this data we have? If John ate 80 calories as well as Norman, we can say that Peter also ate 80 calories of pizza. Now, the inequality sign will turn into a like this. So we will read this as Peter is greater than or equal to John, but less than or equal to Norman. In this scenario, given the fact that Peter always eat too much compared to John but less than to Norman, it shows that Peter was trapped between the two given values, which are 80 calories. So it forces that Peter must accept this number, which is also 80 calories. And the idea behind this example gives us an insight regarding to the concept of the Squeeze Theorem. Now let us state this theorem, labeled as theorem number 12. Squeeze Theorem. Suppose that the functions f, g, and h are defined on some interval containing a, except possibly at a itself, and that g of x is greater than or equal to f of x but less than or equal to h of x for all x on the said interval. Also, suppose that the limit of the function f as x approaches to a and the limit of h as x approaches to a both exist and are equal to L. Then, as a conclusion, we can say that the limit of the middle function, which is g, as x approaches to a exists and is equal to L. Now, it only tells us that if we have three functions f, g, and h written in this manner. Now, if the limit of the function f is just equal to L, and the limit of h is also equal to L, together with this inequality sign, we can say that the limit of g as x approaches to a is also L. Now in that case, we will put underscore here to indicate that these limits are equal to each other. Now let us provide some examples for us to interpret the Squeeze Theorem geometrically. Let's say we have these functions f, g, and h defined by this. We have a negative 4 times the quantity of x minus 2 squared plus 3 for f, and the positive version for that must be our h of x. Then our concern is to find the limit of the middle function, which is g. Now the graph of g is a parabola with vertex at 2, 3 deleted. Function g is not defined when x is equal to 2. So if we try to substitute 2 in variable x, it will turn into a 0 denominator. So bawal yun. If we try to graph this one, this is the graph of our middle function g. Now the graph of f and h are parabolas with opposite signs. So if the numerical coefficient of a is positive, the parabola is opening upward. Otherwise, parabola opening downward. Observe that the hollow point on this location was replaced by a solid point since the functions f and h are continuous. Notice that for all x except at x is equal to 2, we have this. G of x is greater than or equal to f of x but less than or equal to h of x. As we can see, on our illustration that f is the lowest graph in our Cartesian plane, and this color green parabola contains a high values of y, so that this must be the largest function among these three, and obviously g of x is the middle function. Now if we try to determine the limit, or if we try to compute the limits of f and h, simply apply the limit theorems, we will obtain 3, both. So if that's the case, by Squeeze Theorem, we can say that the limit of g is also 3. Let's have another example. Let's say we have these functions f, g, and h defined by this. Notice that f and h are simple functions. These are parabolas. Compared to g involves a trigonometric function, so it will be difficult for us to find its limit. Let's say our concern, or if we care about the limit of this function as x approaches to 0, what's the limit? Anyway, this will be the graph of these functions. We have h, the largest function, since this was located on the highest part of the Cartesian plane, while the blue parabola located at the lowest part, and the middle function will be g. Now if we try to construct the inequality of these functions, we have g of x greater than or equal to f of x but less than or equal to h of x. So simply get the limit of f and h as x approaches to 0. So we will obtain 0, applying the limit theorem number 5 or 6. I think that's the limit of the nth power. These are both 0. So if that's the case, we can conclude that the limit of g is also equal to 0 with the help of the Squeeze theorem.